Hello, and welcome again to The Franklin Effect. I'm Dr. Franklin. That's me. And be sure to hit the subscribe button if you like this show. In this episode, we're going to talk about infinity, gravity, mass, and weight. Hello, young scientists. It's Dr. Franklin again. First things first, I strongly invite you to leave comments below, questions, etc. And I can be reached at thedoctorplace@gmail.com. And please hit subscribe below if you like the show. The last time we talked about the scientific method, we covered a few topics on which I would now like to go into more depth. I want to talk more about the concept of infinity and also gravity. And what's the difference between mass and weight? Infinity. What is infinity? Infinity is a very, very, very large number and then some. So think about infinity as the biggest, largest number or distance in space that you can think of, but then multiply it times itself a billion times and then take that to the billionth power and then keep multiplying that times a billion and a trillion, zillion, gazillion times and then some. That's infinity. So it's not so much an actual number as it is an idea that we use in science and math. It's easy to think of infinity as a barrier or limit, but it's really not, because unlike all the rest of the numbers that we use daily, you can go on infinity times more past that limit. Infinity is not a limit or a contained set of numbers. It's just an idea. Now look at the number 10. That's a definite limit. I can count 1 through 10, and everything inside 1 through 10 is contained within 1 through 10. We can think of 1 through 10 as a container with limits. This is all container here, and this is everything that is not container here. 1 through infinity is not really a container at all because you can keep going and going and going.
Kind of like you.
There's
right?
almost infinite stuff that isn't in this container. In fact, infinity is everything minus the container plus the container. And that's what makes it so difficult to really contemplate what infinity means, because we humans naturally think of numbers as being sort of a container. There's a beginning and an end. We struggle to see it otherwise. And there's some practical reasons for this. If we're thinking about speed, we think of a car going 60 miles an hour, or 100 miles an hour, or 200 miles an hour. But we don't think of one going infinity miles per hour because there's obvious limits to how fast the car could actually go. And throughout the series, we're going to talk about what causes those limits. It's easy to understand why we think in terms of limits. Thinking in terms of limits is part of what helped us survive. Being able to understand infinity is not a very useful tool when it comes to survival. But knowing the limits of a tiger is a very useful tool for survival. You see, here's a tiger, and if you look at this end, you see a tail. And if you look at this end, you see a rather sharp, pointy, dangerous part that you really want to avoid at all costs. Because if you don't, you're going to end up right back over here by the...
Nope, stop that. Too silly. And no Baskin jokes. Now carry on.
Sorry about that. When it comes to science and physics, it's important to understand the concept infinity because it's basically a limit that nothing could ever actually achieve in reality. But understanding that is what helps us understand the rules that do guide reality. Nothing in nature achieves infinity. There's never infinity butterflies. There's never a star that's emitting light traveling at infinity miles an hour. There's not infinity stars in our galaxy. Nothing weighs infinity pounds or has a mass of infinity kilograms. Although we can think of the universe as having a mass of infinity.
That's heavy.
But that's not a useful idea in the scale that we typically measure things. In other words, infinity has some great use in the universal sense in helping us understand the laws that guide reality here on Earth, but in a practical sense, we never see infinity. Okay, hopefully that idea will become more clear as we go on into other episodes. So we talked about gravity. In particular, I want to talk about gravity here on Earth. All things have a gravitational pull, but I just want to stick with the characteristics of Earth's gravity for this discussion. Gravity causes acceleration towards the center of the Earth at 9.8 meters per second per second. Let's do a sidebar on acceleration versus velocity. Say a car driving down the road for 1 hour ends up at a location that is 50 kilometers east of where it started. The velocity was 50 kilometers per hour east. Now that creates some weirdness for us. We normally just think of a car driving 50 kilometers an hour. But when we think of velocity, there's also a direction involved. Not so important right now, but important later on as we understand different things about physics. In a velocity or speed, we think of a distance over a unit of time. In this case, the number of kilometers the car travels in an hour. It's the change in distance over a change in time. With gravity's acceleration, we set a distance over a unit of time over another unit of time. Acceleration is a change in velocity over a unit of time. And that's why you get meters per second per second. Meters per second would be a form of velocity, although not velocity in the formal sense because velocity always has a direction involved. And so does acceleration. An apple that was released from the tree branch is initially moving at 0 meters per second, and as soon as it is released, it starts accelerating, going faster and faster towards the center of the earth at 9.8 meters per second every second. This can get complicated, and we'll go into gravity and falling objects and that type of stuff in another episode. And now another sidebar. You might be puzzled why I always say center of the earth. In a practical sense, when things fall, they fall to the ground, which is the surface of the earth. But they don't go all the way to the center of the earth, owing mainly to the things that beat it there. But say we had a tunnel all the way through the earth's surface from one side of the earth to the other. Now, if you happen to step into the opening, you fall, and you will keep falling until you reach the center of the earth. But then you keep falling, except now you're falling incrementally slower and slower and slower because now you're past the center of the earth and you're now being pulled by a gravity in the opposite direction. Because remember, gravity pulls you towards the center of the earth. So when you fall down the hole and you pass the center of the earth, now all of a sudden you're technically going to be falling in the other direction. Decelerating at 9.8 meters per second per second. Deceleration is simply acceleration in the opposite direction. Your momentum carries you past the center of the earth, but you start decelerating at 9.8 meters per second per second. Let's go back to the beginning. We were talking about the crust of the earth's surface. And we come across this hole, we jump in, and we immediately start accelerating at 9.8 meters per second towards the center of the earth. Once we have passed the center of the earth, now even though we are still moving towards the other side of the earth, we are actually decelerating at 9.8 meters per second. So here's a question for you. What happens when you finally stop moving, meaning that your velocity from your fall has now reached the exact point where your deceleration has completely canceled it out? Now you're going to actually start moving or falling back towards the center of the earth, accelerating in the opposite direction. As you can imagine, once you pass the center of the earth, you're going to start decelerating again until you reach a point, and then you're going to start falling back towards the center of the earth again, and so on and so on. Now, there's way more things I can talk about with this, but since it suffices to say when we fall towards the center of the earth. If we were to, in theory, be able to find this tunnel that goes all the way through the earth to the other side, and we ignore the fact that the center of the earth is really, really hot and would essentially incinerate us, that gives us the understanding of what gravity does to us on earth. We would eventually lose momentum in the fall and stop moving right at the center of the earth. So let's talk about the ideas of weight and mass. I live in America and people ask me how much I weigh. I'd say 220 pounds. Now, if someone were to calculate my mass, they would get 100 kilograms. So on Earth, I weigh 220 pounds. I have a mass of 100 kilograms. If we look at the correlation between mass and weight, we see that 1 kilogram is equal to 2.2 pounds. Now let's go into outer space. They say that we are weightless in space, and the reason is because there's no gravity. When you think about it, when you weigh yourself on Earth, you're putting a measuring device between yourself and the surface of the Earth. And when you stand on it, Earth gravity pulls you down towards the Earth with a force of, in my case, 220 pounds. But if I got into space and step on a scale, it says 0 because there's no gravity. There's nothing to apply force to me against that scale. But now here's the question. We said on Earth my weight is 220 pounds and my mass is 100 kilograms. In space, my weight is 0 pounds. What's my mass? It's 100 kilograms. And that's the difference between mass and weight. Weight is measuring a force of Earth's gravity and its interaction with mass. Mass, on the other hand, is a measurement of the amount of stuff in a thing.
Completely made up.
That's the scientific definition.
That absolutely is.
So when you take all the stuff in this thing that we call me, there's 100 kilograms of it. And on Earth, that weighs 220 pounds. In space, there's still 100 kilograms of me, but I won't weigh anything. Now, students, I hope this gets you thinking. I've only touched the surface of these things, and there's a lot of questions that haven't been answered today. Please ask me questions in the comments below, or you can email me at thedoctorplace@gmail.com. If you like this, please hit the subscribe button below. And I'd like to thank Parker, who did the vocals for the kitty cat sound.